Compressible flow, question number 2. A gas with a molar mass of 44 and a specific heat ratio 1.67 flows through a channel at supersonic speed. The temperature of the gas in the channel is 10 degrees Celsius. A photograph of the flow reveals weak wave originating at imperfections in the wall running across the flow at an angle of 45 degrees to the flow angle. Calculate the Mach number and the velocity in the flow. So from the question, we know that the molecular mass is 44, and then the K is 1.6, and temperature is 283. You need to change from degrees Celsius to Kelvin. And then from the common equation of Mach number equal 1 over sine alpha here, we could say that uh, with alpha 45 degree, so we'll have Mach number is equal to 1.414. And then from this equation, V equal mc, we substitute all the parameters here. The K is 44 and the molar mass, the K is 1.67, the molar mass is 44, and we could get that the velocity is 422.6 meter per second. So in this situation, we don't use air for this situation. So means that we cannot simply say that K is 1.4. We need to use K 1.67 as given in this question. So the molar mass is 44. So we divide 8,314 with 44 to get the gas constant. So after we solve this equation, we get that the velocity of that gas is 422.6 meter per second.